Peter Kelly-Detwiler, Principal of Northbridge Energy Partners. And in this video chat, we'll be discussing the challenges and opportunities facing power delivery leaders and electric distribution utilities. To help us sort through this important topic, we have Dennis Elsenbeck, Head of Energy and Sustainability at Phillips Lytle LLP Energy Consulting Services. Dennis spent 29 years at National Grid in Western New York, where he was a former VP. For the past 8 years, Dennis has headed the energy practice for Phillips Lytle, providing legal services to energy service providers and helping them to understand the requirements of New York's Climate Leadership and Community Protection Act. Dennis has a deep understanding of the challenges facing a growing distribution grid that must also cope with the impacts of a changing climate. Joining us as well, we have Brett Willitt, a Senior Vice President of Product for ikeGPS. Brett has held multiple positions of leadership during his more than 25 years of grid asset management experience. His electric utility and communications industry experience was a springboard for his shift into the software and technology space, working on utility sector focused solutions, including Spida Software, which was acquired by Bentley Systems, and Osmos Utility Services. He's widely considered one of the leading structural analysis and structural management experts in the United States. So for our first question, we've all heard that the energy industry is experiencing disruption and change on many fronts. And Dennis, I'd like to start with you and hear your thoughts on the broad challenges the industry is facing, particularly with respect to the power delivery function and how those challenges are shifting priorities and processes in the utility industry.
Yeah, thank you, Peter. The traditional manner in which utilities perform T&D is based predominantly on the age of the system, the deterioration of the system, outages, expected load projections, and so on. But what we're witnessing lately is this unprecedented intrusion that is policy based on the T&D planning process, one of which certainly is climate change, which looks at a transition from a fossil to an electric economy with little regard to capacity or resiliency of the actual system itself. Then there's economic development policies that are prompted by the market demand of AI, data centers, chips, semiconductors, et cetera. And that is represented by high demand, high load factor, and high power quality needs. But they're an opportunity for growth if we can capture them. But in a lot of ways, that type of attribute for that type of industry goes against some of the climate policies and attributes, mainly the intermittency of renewable energy. So that has to be considered as we go forward, or we could actually disrupt the stability of the system itself. We're going to need higher level of real-time data, not just static data, from the point of supply to the point of delivery. This is not a time for guessing. The utilities will rely on creativity, the innovation of their engineering team, data collection, and must view planning from a 24/7 perspective via the delivery system based on load factors is no longer suitable. It has to look at a 24/7 operation. And as we introduce more and more distributed energy resources into the system, balancing will become more and more complex, leading to the need for AI at the utility and the independent system operator level.
Thank you. And Brett, coming from your unique perspective, how do you see this unfolding and how do these shifting priorities that utilities are facing impact that physical grid that Dennis talked about?
Yeah, thanks, Peter. I think it's really interesting. As Dennis touched on, we're witnessing a lot of things converging all at once. We've got, this aging infrastructure that's really now tasked with supporting, the interconnection of renewables, increased load demand on the grid, as well as all these climate challenges. So we're seeing utilities put together these really comprehensive CapEx programs that are, we're at the tipping point of really, truly transforming the grid. And I think as they're formulating these programs, I would, strongly recommend that, the utilities look for ways to invest and optimize their technology choices, since really that's going to be the foundation and underpin, the entire execution. So kind of making that kind of a front and center conscientious choice and decision, about the tools and the technology that they're investing in as part of that program execution.
Thanks. So if we can just follow up on that thread a little bit, Brett, what's an example of how utilities can better connect and harmonize their technology investments, and how might this help them improve their return on investment?
Yeah, for sure. So the one thing that we do really well here at Ike is helping utilities manage overhead distribution networks and assets. What people tend to forget is that today there's still 70, and I've heard upwards of 80% of our grid infrastructure is still overhead and aerial. And when I look at the various programs that utilities are executing, around those assets, they tend to be very siloed and functionally run and driven. So we're putting, many people, both contractors and internal resources, into the field in their own bespoke ways to capture and execute on their programs. So ultimately what that's creating is a very, somewhat volatile situation where we just have different qualities of information and data coming in about the grid. So here at Ike, we do really well at kind of with this field to finish mentality, where we're empowering our customers to get to the field for safe data collection and capture, where they're getting data and the imagery necessary to help them make intelligent decisions. We're aggregating all that back into a single pane of glass, where now all parties can collaborate around that data and then ultimately, deliver that data downstream to its respective home, be it into a construction work print if it's a contractor, or potentially back into GIS if there's some type of asset correction that needs to take place. So by leveraging data, ultimately what we're doing is we're creating this efficiency and ecosystem that's really a foundational component for our utility partners, for them to be able to execute all of these respective programs.
So it sounds like connecting the data and technology in that end-to-end manner, or field to finish, as you call it, can have a tangible impact on efficiency. So thank you. Dennis, I know you're out there all the time talking to utilities. What points do you want to add with respect to technology and ROI and how to think about that?
Well, as I mentioned a little earlier, between climate change and these economic development load growth opportunities and AI data center and chips, the traditional CapEx model is under a great deal of pressure as the utilities seek to balance these policy-based priorities with some of their major tenets, and that is obligation to serve, the delivery of safe, reliable service. All of this has to be performed under an affordable energy umbrella. The challenge is real. If you look at internal utility structures, their organizations, they could be comprised of a multitude of different silos that now need to be melded together going forward, whether it be public relations, government relations, engineering, and even where we have account management. They need to be responsible for more integration of market-based data, but it needs to actually be formalized within the T&D planning process, not just a good to know, because the engineers are designing these systems based on what is much more progressive economy that we're facing. So data points need to be integrated in real-time delivery systems with manageable load profiles in a format that, kind of like utility engineers are designing those systems of the future to ensure that energy policy embraces a much more efficient, resilient energy market system driven by market demand, not simple policies. So melding real-time data with projected load growth, climate-based resources, the rise of distributed energy resources, we need to think about how to stabilize the electric system, because that's going to be key going forward, or we all risk looking at brownouts and unstable electric systems, and we'll actually miss the opportunity to drive down unit costs as we bring in these larger loads combined with the climate, so that they all contribute to the fixed cost of the T&D process. So as a society, we need to accept the challenge of how we manage our electric system And to do that, I think policymakers must turn to the utilities, allow them to lead this conversation, and get away from having them follow or chase policy trends.
Thanks. And Brett, you mentioned before so much of this is overhead. I'd love to cycle back a little bit to that in that space where you're looking at what's happening specifically at the pole level. Certainly,
Yeah.
climate is one of those pieces there. But what are the value added benefits you see when you focus on that particular space?
Yeah. I mean, again, Dennis spoke what I heard Dennis talking about, that there's a lot of stakeholders invested in these assets, both internal and external, you know, um, and so again, I'm going to come back, and I think the value is in that data by placing data into an environment where it can be orchestrated and then used for collaboration between all these stakeholders is really the foundation for business execution and velocity, because ultimately, it's about sustaining and improving the grid. And, we're all here for different reasons and drivers. So there's a lot of noise, respectively, right now that come from both internal organizations and external. So that creates friction and slowdown. So if we can optimize and leverage the data as kind of almost like a baseline and a benchmark for decision making and program execution, that's going to be key. You can simply look, we'll as an example, we can talk about joint use, which is the collaboration between pole owner and pole attacher. There, there's an opportunity there, because when you have an attacher that's looking to execute their program, if there's a disconnect between the quality of the asset information, so where are my poles located, or what's the state of those assets, obviously that's friction for both parties and a challenge. So there's an opportunity to kind of marry around the data for collaborative execution and velocity. I can look at a utilities ground line pole inspection program, which is kind of looking at that conditional assessment, making a determination on whether or not utility poles need to be replaced. Too often, we're seeing utilities simply take the output of those pole inspection programs and go out for a like for like replacement. There's an opportunity by leveraging the data, to effectively, run that through additional structural analysis, and using purpose-built AI to look for trends and patterns, across the data. Ultimately, it's leveraging the data, to better enhance various programs in a common place.
Thanks. Well, it strikes me in this very brief conversation that this is not your grandfather's utility anymore, nor even your father's utility at this point. We're talking about cyber-physical entities where we need accurate data that we turn into actionable, useful information that gives us the situational awareness we're going to need moving forward. You've both given us a great deal to think about in this short conversation, and how utilities across North America need to rethink their approaches to a lot of these critical issues at a time when electricity's never been more vitally important in driving our economy. So thank you for your insights today.
Thank you, Peter.
Peter.